Hello friends, today I'm going to talk on space pollution which requires proper management. As we all know, the space debris sources are majorly discarded hardware such as launch vehicle upper stages, space and mission operations such as deployment and separation, material degradation, uh, which material degradation due to atomic oxygen and solar heating and solar radiation, which has resulted in the production of particulates such as paint flakes and bits of multi-layer insulation. Any concentration of space debris particulates or fragments in a well-defined region of a space which is referred as a debris cloud. A major contributor to the orbital debris background has been the object breakup, which generally caused by the explosion and collisions in space. Whenever an orbit breakup occurs, a debris cloud is instantly formed. Such debris clouds first takes in the form of expanding a 3D ellipsoid which eventually envelop the entire orbit and any other satellite in the nearby vicinity. If the space debris size, the debris cloud formation we have, this image shows the example of debris cloud formation when China impacted the different satellite with the anti-satellite missile in 2007. Now, if the debris size is less than 1 millimeter, then it erodes we'll go for the risk assessment. If the debris size is less than 1 millimeter, it erodes the sensitive surface such as the payload optics, which leads to payload degradation. If it is between 1 millimeter to 1 centimeter, it may or may not penetrate a spacecraft depending on the material selection and whether the shielding is used. And if it is larger than 1 centimeter, it penetrates and damages the most of the spacecraft, which leads to the functional termination of the body. Here in this image, we can see that the damage of the space shuttle orbiter by space debris piece sizing 0.2 millimeter. The risk is best controlled by limiting the creation of debris through mitigation based on the general IIDC space debris mitigation guideline, which focuses on preventing on-orbit breakups, removing the spacecraft and orbital stages that have reached at the end of their mission operation from the useful densely populated orbit regions, and limiting the objects released during normal operation. To prevent explosion, satellite components that store energy can be passivated at the end of useful life. Based on the IADC guideline, any activity that takes place in outer space should be performed while recognizing the unique nature of the following region, which is shown in the figure of the outer space, region A and region B, to ensure their future safe and sustainable use. This projected region should be protected regions with regards to the generation of the space debris. To prevent debris accumulation in preferred mission orbit due to collision, satellites and other objects must be removed from the mission orbit at the end of life because collisions are likely to occur. It is generally recommended to place vehicle in the disposal orbits, which is also known as graveyard orbits. Many spacecraft in the geosynchronous orbits are already boosted in the hard disposal orbit at the end of their mission life. In more distant future, it may be necessary to completely remove all the satellites and upper stages from the orbit. This removal will not be feasible until new technology is developed. The amount of debris on orbit in future will depend upon whether the creation or removal rate dominates. Currently, the only mechanism for the removal is orbit decay through atmospheric track, which is ultimately leads to re-entry. This mechanism is the only effective in a restricted region of a low Earth orbit. At higher orbits, it takes hundreds and thousands of years for an object to re-enter, and so there is no effective removal mechanism. Historically, the creation rate of a debris has outpaced the removal rate, leading to a net growth in the debris population in low Earth orbit at an average rate of approximately 5% per year. Because of the increased number of larger objects, lack of sufficient debris mitigation efforts such as collision avoidance could eventually result in a collision-driven population growth. Various technical models of population growth have been developed by the international community. Most models agree that the rapid population growth can occur in the absence of appropriate debris mitigation. Thank you.